When Toyota needed a power plant for the modern Supra, they bypassed their own catalog and chose a BMW inline six. The B58 has become so respected for its durability that it is widely referred to as the modern 2JZ. This reputation is a radical departure from the previous decade. Earlier engines like the N55 and the N63 were notorious for catastrophic mechanical failures, ranging from warped timing covers to shredded rod bearings. BMW was under immense pressure to change. Their modern vehicles had become much heavier and more powerful, yet they were being squeezed by increasingly strict global emissions and efficiency standards. Patching up old designs was no longer an option. Surviving this new era required BMW to scrap their existing blueprints and rebuild their foundational engine architecture from the ground up. Every legendary trait of the B58 is the result of BMW's deliberate, iterative extermination of their historical weak points. The B58's strength begins with its modular 500cc cylinder blueprint, a design it shares with the B57, BMW's heavy-duty diesel engine. Older gasoline engines used open-deck blocks with hollow cooling channels. Under high boost, unsupported walls flexed and warped. The B58 adopted the diesel's closed-deck geometry, sacrificing coolant volume for a solid aluminum top, creating a structure that securely cages explosive cylinder pressure. This reinforced block was paired with a drop-forged crankshaft and fracture-split connecting rods, both capable of withstanding massive levels of low-end torque. By transplanting the skeletal structure of a diesel truck into a gasoline sports car, BMW created an engine block capable of handling huge aftermarket power without fracturing, but the block's strength was only half the battle. Modern start-stop technology creates a new type of wear, forcing engines to fire up before oil pressure can fully build, which leads to destructive metal-on-metal contact. To fight this, BMW coated the rod and main bearings in IROX, a highly durable red resin matrix. This chemical shield manages the friction of daily startups until the mechanical oil pump takes over. These thermal graphics show the extreme temperature gradients and heat concentration that build up inside the cylinder walls. These daily fluctuations force engine internals to expand and contract, causing significant fatigue over time. The B58 counters this with a heat encapsulation system, a thick acoustic and thermal insulation wrap that traps residual heat inside the block for up to 36 hours after shutoff. By keeping the engine perpetually warm and chemically shielding the bearings, BMW effectively eliminated the daily microabrasions that usually limit an engine's lifespan. Historical timing chain failures were another major target. Aggressive gear shifts send violent kinetic shocks up the crankshaft, which in previous designs would travel to the front of the motor and shatter the timing components. BMW's fix was a total geometric relocation. They moved the entire timing chain assembly to the rear of the engine, allowing the transmission bell housing to absorb the direct kinetic shock of performance driving. They also moved the Valvetronic actuator lower into the cylinder head. This ensures the gears are constantly bathed in oil, preventing them from running dry and shedding metal shards into the engine. Relocating these sensitive synchronization systems physically shielded them from the brutal physics of the high-performance driving they were designed for. While the internal rotating assembly is a nearly unkillable vault of forged metal, it is surrounded by external components compromised for weight and production efficiency. Owners often refer to this as the plastic tax. The primary vulnerability of the B58 is its polycarbonate oil filter housing, which has become the subject of major class action lawsuits. Because this housing is made of plastic and bolted to a high-heat engine, repeated thermal cycles cause the material to warp and crack. This eventually leads to coolant leaks or the dangerous mixing of coolant into the engine oil. Other high-heat victims include the expansion tanks, coolant outlet flanges, and PCV valves, all of which are prone to crumbling after several years of operation. The B58 earns its bulletproof reputation because it will almost never suffer a shattered block or a spun bearing. But owning that unkillable metal core requires a trade-off, treating those external plastics as mandatory consumable maintenance.